last time we mentioned about how we can doing that is that we so starting from the question, so it's actually going to having a 3D space, kind of like the three-dimensional coordinate plane, and then we're going just to from 0, 0, 0 to n, and then we're going to just giving the coordinates x, y, z. We're going to kind of like dig out that block, and then finally we're going to see how many the stick one by n brick could add into that so that there's no part of the brick will overlaps with other remaining chips. And then, as I mentioned about last time, like how we can solving that is we firstly trying to simulating this like giant cube. So from 0, 0, 0 to n, and then we are going to, so for every times we given the XYZ, and then we that uh dig that block, and then we're just trying to check or count like how many n by n, one by n block breaks could take into that. So we are going to just returning that. So that's kind of like the briefly solution of that. Um, so and so last time I think I kind of like giving you a pretty, I think a little bit complicated things. We assuming when we simulating the block, we having the 3D, we have the 3D array list or 3D, kind of like the list, and that's a little bit complicated. But if we split it to uh, three arrays, three 2D list, so assuming we having this block, and now we having the X, Y, Z, and then we could assimilate that as the three directions. So for example, we could having the X, Y, so which we assuming we having the plan of the X, Y, and then we having the plan of X, Z, and then we having the plan of the Y, Z. So for each for each directions, and then we will assuming we having the we're having the plan. It's kind of like we having the n by n plan of that, and now we assuming we're having three that kind of list. So in that list, and then we will only need to count for every single list. We just run through that, so that will kind of like running the more faster. And so that's also how we try to count it in the case of one by n, or one by n by one, or um n by one. And then we that's also easy for us to tracking that as well. So that's why for the different, let's say direction or orientation, and that will be easy to counting, for example, like how many positions has already been dig out, and to say that if that is kind of like continuously. And we also need to check in the boundary of that. So for example, in the Python, we can just do let me do this. So we could just having, so firstly we read, let me add this as well.
Uh,
So firstly, we having trying to read the input, and then that will be, we can also kind of read the input at the first case. So then that will be, we read the 2 and 5, so the first two digit. So that's we read the N and Q, and then for every time, so for the N dimension, and then we're actually for the, so the N is kind of like how the dimension, like how many, like N by N Q we're going to simulate, and the Q will be kind of like the number of the operations we have. So for the next 5 lines, for example, in this case, and that's kind of like the operations we will have. So for example, if we have for in the range of the Q, and so that's kind of like like how many operations we're going to read. So for every time we can read Oh, okay, hold on. Before that, so create. We can also simulate or create the the, the three the 3D cube. And then so we could have in the three orientation or direction plan. So that would be so for each plan we're having the n by n. So that would be 0 0 to the times n and then in the range of n. So doing that, we're actually going to simulating the the a 2D list or in that plan that we're having the n list in this big list we're having the n sublist and which each n sublist will becomes the n's like the 0 times n times and then so that's kind of the plan that means that is full right now and we can just do we can also doing the similar thing to the XD and then I think that would be also be the similar thing to this one as well. So for three directions, we're doing that in the similar way. And then and next we are going to having the count equals to 0. And then we're going to actually simulating that. So we firstly read the inputs of the each operations. And so we're having that XY. And then so we know that for every time when we're trying to calculating the numbers, and then we can always just kind of like we defining the coordinate corresponding to three planes, and then we add that integers to one. So and that means that at this position it's already being dig and also similar thing to like how many times I will add it. So for example, so if I got this point at firstly simulating that I'm going to dig that block. So for example, for XY and then the X and Y position, and then we're going just to add one. And then similar thing to, let me add the comment over here. So I believe that will be all of the questions. So if we can just simulating the test cases of the oops, sorry. If we can just simulating the test cases of this one, and then for example, if we having the 2 and 5, and then we for every time we're just gonna input that. So actually, I can do the input myself. So if you're just running that, and then we're having 2 and 5, I believe I have 0, 0, 0. We're having 1, 1, 1. And then we having the 0, 1, 0. We having 1, 0, 0. We're having 1, 1, 0. And so we can see the output is actually 0, 0, 0. Oops, hold on. I think I kind of like, oh, hold on. I think I might do a little bit wrong. So every time when we're doing that, we need to check that directly. So I think the better way doing that is we having the after we adding that, we just do something like this. That's so that our content will keep adding. I think something like this. Let me going to change it. And so we are, let me double check if that is right. Five. And then we having 0, 0, 1, 1, 1.